Good afternoon, everybody, and welcome to today's webcast entitled The Effects of Climate Change on Urban Stormwater Management. My name again is Lula, and I'm with RV Anderson Associates Limited, and I'll be assisting in moderating this webcast today. To get started, I thought I would give a brief background on RV Anderson Associates Limited, today's presentation, and most importantly about Hans Arias, our speaker. RV Anderson Associates Limited is a professional consulting engineering firm made up of professional environmental and infrastructure specialists for water, wastewater, transportation, and urban development. The company is owned by its principals and associates, providing services to public and private sectors in Canada and internationally. Today's presentation, The Effects of Climate Change on Urban Stormwater Management, will provide an overview of the predicted effects of climate change on urban stormwater management and will outline some practical approaches to best adapt our planning and design activities for urban stormwater management infrastructure. Today's speaker is Hans Arias. Hans is a professional engineer and a senior associate of Hydrocom Technologies, which is a division of RV Anderson Associates Limited. He has 2 decades of experience as a consulting engineer specializing in hydrology, hydraulics, and stormwater management. In addition to his design work on numerous drainage and stormwater management projects, Hans has recently been involved in the development of a protocol for the first national engineering vulnerability assessment of Canadian infrastructure to the effects of climate change and the application of this protocol to roads and associated infrastructure in Sudbury, Ontario, and drainage and stormwater infrastructure in Placentia, Newfoundland. So, without further delay, I will pass it over to Hans.
Thank you, Lula. I trust everybody can hear me. As the title of my presentation indicates, what I would like to do today is try and quantify the effects of climate change and see how those predicted effects will impact stormwater management in general and urban stormwater management in particular, as urban stormwater management, in my opinion, is the trickiest of stormwater management aspects, as it provides some interesting special challenges. So, having said that, this would be the outline of my presentation. The subtitle would be A Changing Landscape, because I believe, and as you will see during the presentation, some of the predicted effects of climate change really require us to take a hard look at the way that we've been doing the planning and design of stormwater management in an urban setting. So, first thing that I'd like to spend a bit of time on is let's take a look at climate change. There's a lot of information out there. I would like to review the various sources of data that are available and try and get a handle on how big and significant these changes are as they relate to stormwater management and, basically how fast they're coming at us. So once that's done and we get a handle on that, I'd like to take a look at the planning and design associated with stormwater management, the way we've historically done business, and what kind of changes we would have to make to those processes in order to make sure we don't paint ourselves in a corner. I'd like to review some of the options that we have available to adapt to these predicted effects of climate change as they relate to stormwater management. And those components really will form the bulk of my presentation today. However, just to provide some context into the other aspects that will impact on stormwater management, I'd like to very briefly review the hydrologic effects of urbanization and how the processes that we all have been using for, say, the last number of decades compare to the changes we will have to make to accommodate climate change. I will also very briefly touch on the water balance requirements that have been on the books now for a few years in southern Ontario and how that compares to, again, adapting to the predicted effects of climate change. And I'll have a few concluding remarks at the end of the presentation, following which I will be more than happy to answer any and all questions that anybody may have. So having said that, a changing landscape. What I'd like to do is get a handle on predicting the effects and magnitudes of climate change as it relates to stormwater management. We'll take a look at trend analysis, which is a tool in that particular box, global climate models and regional climate models, and do a bit of a synopsis on the data that's out there to basically try and get a handle on how bad is bad. Then I'd like to summarize those results and basically formulate the challenge as I see it in how we're going to accommodate these changes in the way we design stormwater infrastructure. So having said that, predicting climate change, there's two ways to predict climate change, and two is in quotation marks because I list three sub-bullets. The first, and I'm a firm believer of this particular source of data, is trend analysis. Basically what happens here is we take the historic records from Environment Canada climate stations, and we'll basically plot trends in temperature, precipitation, wind, whatever we have over time, and see whether there's an increase or decrease over the last number of decades, and then project that trend out into the future, and basically see what kind of predictions we can make from that. Next source of data that I'll be looking at would be global climate models. They've been around for a decade and change now, and basically consist of computer model simulations of the climate around the entire globe. Downside of these results is that they're fairly coarse, and in response to that coarseness of data and the need for more detailed information at the local level, recently regional climate models have been developed that are basically nested inside these larger cells and provide more detailed data. Before we get into the exercise of taking a look at this data, one of the things that I would encourage very strongly is that when we hear news in the media related to climate change, and before we take a look at the next data that I will go through, we have to basically provide a bit of background for that. I find that the information that's presented in the general media in particular misses some of the nuances, and in some cases that will result in the data being either incomplete or downright incorrect. So first thing that I normally review when I take a look at climate data, is it hindsight or is it foresight? Hindsight would be trend analysis, so that's data that we have already seen and is basically irrefutable, or is it foresight? In other words, is it the results of computer models, which are based on a truckload of assumptions, and there is a lot of variability and uncertainty associated with a lot of those predictions, as we'll see in a minute here. The next four bullets that we have up on the screen now, I guess, relate to the, what is the variable? Are we talking temperature, precipitation? If we're talking precipitation, is it daily average precipitation, or is it, instantaneous extreme precipitation? The next thing would be, what's the spatial scale? Is it local or is it global? Basically global results can hide a lot of spatial variabilities, I guess. And the next thing would be the temporal scale. Is it annual or seasonal temperature